Hello, my name is Krus. Today we're going to look at how you can use the negated blocking firewall policy approach in VMware NSX in order to create yourself a system-wide security posture using guardrails. We will also see how VMware vRealize automation may be forced to be compliant with your guardrails and push virtual infrastructure into this security posture that you have created in your VMware virtual system. The idea of negated blocking approach it has been around for quite many years now and is in use by many of our customers. And it basically boils down to that you set yourself a bunch of security dimensions that you want to use as guardrails, and then you create security tags for every dimension. So in this first example, I would like to, being the system owner, I would like to isolate my different tenants that I have in my system. I have created specific security tags for each tenant, and everything that each tenant push into the infrastructure is tagged with a tenant-specific security tag. If I then push these two rules here, this one and this one, I will make sure that I guardrail my different tenants and isolate them from each other. The rule looks a little bit reversed or containing reverse logic, you may say. So basically what I say using negated blocking is that if you are not belonging to a specific security dimension, trying to go towards something, then I will block you. So if we take the tenant separation, tenant isolation as our first example, then I say that tenant 1812 negated as a source going towards the tenant 1812 is rejected, meaning that any other tenant cannot go towards anything that this specific tenant has created into the system. And then I push such a firewall policy rule for every tenant that I have. That will be my first guardrail, or at least the first example. So what I'm using in this specific example is that I'm using the distributed firewall of VMware NSX. And as you remember, the DFW is something that kicks in the outside, just outside the VNIC of every VM. So everything going in or out of anything that you provide in your infrastructure will be filtered by the distributed firewall. And in this example, we will use vRA to be compliant with our guardrails, and we would like to make sure that the consumer in vRA can influence certain things, but not everything. So imagine that this is my vRA consumer, and I would like to provide the ability for this consumer to log in to vRA and kick off deployments. Part of the onboarding, we know the identity of this specific consumer, we know the tenant of the consumer, and we know by asking a couple of different questions where the stuff that he is about to deploy will be squeezed into his infrastructure. So in this type of environment, we have in this specific demo agreed upon a couple of different dimensions. So first of all, of course, we need to know the tenant and the ID of the consumer. This is in order to provide connectivity from a management point of view to start with. So when he deploys a deployment, that deployment may contain a bunch of VMs like this. So this is now my VMs from a logical point of view. All right. What I would like to provide here is the ability for the consumer to kick off multiple deployments like this, potentially from the same blueprint even, but they should be isolated from each other because they are different deployments. So we would like to have a deployment isolation idea. This is something that will be brought in by vRA. I would like to bring the ability for my consumer to manage stuff. So since he is the deployment owner, he should be able to manage the stuff. That is not the same thing as influencing how certain things may be reached from outside. So this is something that I refer to as ingress. Other than that, I would like to have my consumer to influence what environment this should be in, potentially if there are different security zones or security levels on certain things that he deploys into the deployment, and a couple of other things. So let's have a look at the policy rule set that we have chosen in this particular setup. I am now logged into the GUI of VMware NSX, and let's have a look on what this specific demo setup looks like. So let's start with networking, even though it's very simple. So I am the provider. I have created myself the provider T0 router that connects to the outside world. I have created part of the onboarding a tenant-specific T1. And the reason for this is potentially I would like to have tenant-specific netting. Maybe I would like to terminate IPsec tunnels specific to a certain tenant, or whatever is my need. But other than that, from a segment point of view, I have only created one segment per tenant, and I have chosen a quite large /20 IP segment, because I will not use subnetting as my way to enforce guardrails. I will use negated blocking instead, using the distributed firewall of NSX. So from here, let's go to security and the distributed firewalls, and let's have a look on how negated blocking works, and also how VMware NSX kicks off the different policies. So to start with, VMware NSX has a bunch of different tabs, and you as a system owner, security administrator, have the ability to push certain policies into each of these tabs, and they are executed from left to right, and within a certain tab, it's a straightforward first match top-down approach. So in our setup, let's start with emergency. We are not really using anything on Ethernet level, so I'm not filtering on MAC, but what I do have is two security guardrails, two security dimensions under emergency. And this is because our imaginary company works out of Northern Europe, so they are having business, let's say, in a couple of different countries. And just to be cautious, in the happening of an emergency, I have the ability to isolate countries. Remember that everything in our environment is tagged with the tags of our choice. So in this case, I have tagged everything belonging to a certain country. So if I have the need to going forward, I have the ability to isolate different countries from each other because they have different laws, they are different countries. Using negated blocking, it will look like this. If you're not Estonia, going to Estonia, I will block you. If you're not Finland, going to Finland, I will block you. If you're not Norway, going to Norway, I'll block you, and so on and so on. However, these are emergency rules, so I will have them disabled, and hopefully I will never turn them on, but I have the ability to do so if an event occurs. The same thing with the different data centers or availability zones that I potentially have. So imagine that I have a bunch of different data centers, and potentially in the future, I have the need for isolate certain availability zones or certain data centers. Then I have tagged everything that runs in my infrastructure with a availability zone tag, and I potentially may, if I so need in the future, have the ability to block them away from each other. But this is not everyday business, this is emergency. So let's instead go to the next tab, the infrastructure tab. As we said, we would like to have the ability for our tenants to manage the stuff that they provide into our system. So what we have done is that we have created AD groups, and we are consuming those AD groups as security groups in VMware NSX. So if I belong to the AD group of a certain tenant, going towards something that has been tagged with a tenant-specific security tag, this is allowed because I am the system owner, or I am the deployment owner. In the service, in this example, I have settled with SSH, but of course you can enable and turn on any service that makes sense for your management. But remember that this is only management. I have also enabled a bunch of infrastructure rules that are common for everyone in my system. It is allowed for everyone to use DHCP, neighbor discovery, network time protocol, and DNS, and potentially something else that makes sense in your system. Okay, most of the stuff that belongs to my negated blocking guardrails happens under the environment, at least in this demo setup. So we have already seen that we have isolated the tenants from each other, and each tenant ability to isolate environments. And note that there is no overhearing between the different dimensions. So if I start with isolate my tenants from each other, each tenant may reuse the security tags in order to further isolate and further push guardrails into the system using the same upside down reverse logic. So if you are not environment production going towards production, I will block you. The same goes for security levels. And by now, typically the question comes, okay, but what if? What if I have some special need for something in test to, for a certain period of time, reach a database in production, let's say? Well, then we see that as an isolation override. So remember that NSX, just like any other firewall, has a top-down first match approach. So if I were to push something into this section here, the isolation override, I have the ability to bypass my blocking dimensions further down in my rule system. So if I have something specific here, I may say that, yes, this particular source with IP or tag or whatever is allowed to reach this specific destination, a certain IP tag or whatever on this specific L4 service, L7 service. And then I apply that. Now I am effectively bypassing my guardrails. This shouldn't be done by the consumer. This should be done by the security administrator, and only if you need it. I will remove this rule for now because I don't need it. All right. We also said that we would like to have the ability for the consumer of vRA to influence the ingress of certain things, such as a web ingress or something in his deployment. So what we have done here is that we have created an ingress dimension where the consumer may influence and say that I allow, from my perspective, to let this particular VM be reached from something outside of my guardrails. And in this particular setup, we have created internet, partner, and office as our dimensions, but those could be, of course, any pre-approved access port opening. In this particular case, we have created 1, 2, 3 networks. We call them LB-VIP because outside of our system, we have our load balancer. So basically, the consumer of vRA will say that I allow my load balancer to push traffic towards certain ingress that I have. Other than that, everything here should be guardrail, and I am the system security administrator. So what I do now is that I have a set of guardrails that guardrails my infrastructure in the way I would like to. And now I hand over to the consumer of vRA to do deployments. And in those deployments, he has a number of choices to place stuff within this infrastructure. And what I will do is that I will let the consumer push stuff into my application level and also to my deployment isolation. And this is done by vRA. Okay, so here's a summary sketch of what we have been talking about, the negated blocking guardrail dimensions. We start up from left under emergency. We have isolate regions or countries. Within the countries, we potentially have availability zones. These rules are disabled during everyday business, but they are there so that we can enforce such a guardrail. Under infrastructure, we have the first rule there, allow east-west outgoing. So this is a matter of taste. What we have done in this demo is that we have focused on blocking on ingress, and therefore we have one rule that allows within the data center everything in outgoing direction. This means that we will block on ingress. If you feel like it, you can block already on egress just by doubling all of the rules that you have. We also under infrastructure have the allow infrastructure, DNS, NTP, those kind of things, and allow management, the tenant management. The tenant should be able to manage in every way they want the stuff that they own within the tenant. And then going to an environment, we start off with isolation override. This is where we have exceptions, where we want to do an override, basically with the action jump to application. So we basically jump by the blocking dimensions over to application tab. Then we have isolation of security levels if we want to. the approved ingress, same there. Either we approve them right away, or we can do the jump to application. Isolate tenant from each other, isolate environments from each other, isolate deployments from each other. And the deployments, under deployments, we have dynamic firewall rules placed there by vRA using a script. And then finally, during application, we have a default block, but the applications themselves from vRA may shoot certain allow rules, and that would be influenced by the application owner, the consumer that makes the deployment. So what I will do now is that I will hand over to our vRA expert, Lars Olsson, and he will show you how he can push stuff from his vRA, and this will be compliant with my security guardrails that I have, being the system owner of VMware NSX.
Hello, my name is Lars Olsson. In this demo, I will be using vRealize automation to automatically provision virtual machines that are compliant with the security guardrails that Anders just showed us. I will start off in the NSX Manager UI, where I will show you now that we have a clean environment. We have no virtual machines deployed. If I switch over to my distributed firewall, I want you to take notice that we do not have any firewall rules created in the isolate deployments policy. I will now switch over to vRealize Automation Service Broker, where I, for the sake of this demo, has built a simple Linux-based service consisting of a few Linux VMs. I will go ahead and request this service. Here I'm presented with a few options. So I need to give my deployment a name. I get to choose what availability zone I want to deploy this service into. I will go ahead and choose Stockholm primary, and then I'm picking my environment and the number of virtual machines that I want in each of the two different tiers that we have defined in this service. So we have tier 1, which you could see as my front-end tier or my presentation tier. I'm going to go and choose that I want 2 virtual machines in this tier. Next up, I need to set the security level for each tier. So I'm going to go ahead and choose level 1. And I want this tier to be accessed, or these virtual machines in this tier to be accessed from the internet. For my second tier, I want only 1 virtual machine, and this virtual machine I don't want to be accessible from the internet. So I'm going to choose no ingress. This VM will only be available to its partners in the same deployment. So I'm going to go ahead and submit, and the service is starting to build. My deployment is now complete, and I will switch over to NSX and take a look at the virtual machines that I provisioned. We can see 3 virtual machines, 2 front-end and 1 back-end. And I can see that each of the virtual machine has 9 tags represented. Some of these tags comes from the user input that we did in the form when ordering the service, and some has been calculated based on other known information. Like this is a Linux service that I've ordered, so it's going to be running in the Linux platform. My availability zone Stockholm primary is in country Sweden. I can see the security level that I've chosen, the production environment. I didn't enable any IDPS. I have, for this particular virtual machine, I'm allowing internet traffic to reach the VM. So I see the ingress policy being set to internet. My tenant is, in this example, 4711. And I am also attached the deployment name that I entered during the provisioning phase or during the ordering phase of the service. My backend virtual machine has similar tags, except for the ingress policy that I've chosen to set to no, because this virtual machine will not be reachable from the internet. So Anders, would you like now to verify that we are seeing or getting the expected behavior?
Yes, let's do so. All right, so if I go into the vSphere GUI, I can see that 3 virtual machines have been provisioned. So we have 2 front ends and we have 1 backend. And with the current settings, I expect this one here with the IP address 10.3.0.53 and this one here with the IP address 10.3.0.20 to be reachable from internet. We call it internet, but from outside at least. So if I simulate that I come out from the outside, I should be able to reach these 2 machines, the 10.3.0.20. And yes, I can ping it. And the IP address of the other machine was 53. So let's ping 53. And yes, it's reachable. But in this deployment, we chose to not have reachability for the backend server with the IP address .31. So let's see that we are compliant. And yes, I cannot reach the backend server from internet. So the backend server cannot be reached from outside, but I do expect my front ends to be to have the ability to reach the backend. So if I use one of my front ends and just log into to this particular machine here. Okay, so I am the 10.3.0.53 machine. I expect from here, I should be able to reach my backend server. And yes, I can. With the current settings, yes, I can. And if I go into the NSX GUI again, and then I go to security and distributed firewall, I can see that in my rule set, 2 things have happened. First of all, the vRA has kicked up a script that has created a security group and also a security rule that says, if you are not the deployment TP1 trying to reach TP1, I will drop you. So that's the deployment isolation. And if I go to application, we can see that vRA also have inserted a security group with security specific settings for from the consumer in vRA.
So let's kick off a second deployment where I name this TP2 instead. We're going to go with the same availability zone, same environment, same setup in terms of the number of front end and back end servers. So the front ends will be reachable from the outside or from the internet, and my backend will only be reachable by its partners in the deployment. Again, I'm not enabling any IDPS in this case.
So let's just use the whiteboard to explain what we have done. So we have the consumer here. He logs into the vRA portal and he kicks off first 1 deployment here. The deployment has 2 front-end VMs and 1 backend. Same user, same consumer kicks yet another deployment of the same one with these settings. We said that this user from a management perspective can reach the stuff here. But from an access perspective, what we can do is that we can reach the front ends the way we expect them to. But we should have no east-west communication between the deployment. So we would like to close down any way to interact internally if we get like an infection or something within the deployment. So let's verify the expected behavior. Okay, so in the vSphere GUI, after Lars has made 2 different deployments, we have now the total number of 6 machines. They belong to the same consumer, but to different deployments. So this one here, I can see on the tag that this one here belongs to the TP2 deployment. And this is the other front end that also belongs to the same TP2 environment. And this is the backend server that shouldn't be reachable from outside, but it should be reachable within. So the expected behavior here is that since I chose the internet as an access possibility on these ones, I should be able to reach this IP address now, the 10.3.0.186. So let's see that this is the case. And yes, that is the case. So I'm happy with that. But I also would like to verify that I have blocked lateral movements between deployments. So if I take this machine here, the 186, and this machine here, the .53, they belong to different deployments. They shouldn't be able to reach each other. Let's go into this one here. Okay, so I'm logged in at the front end of the second deployment. And I have the IP address that we can see here, 10.3.0.186. I should be able to ping my backend, my second front end, but I should not be able to ping the front end of the other deployment because we have made deployment isolation. So the effect you see here is coming from the fact that NSX under environment has kicked in, need to refresh that, it has kicked in a second rule here that says if you are outside of deployment 2, trying to reach deployment 2, then I will drop you. And the same we had from the previous deployment. So this is something that actually comes from vRA, but it's not a native vRA function. Lars, can you explain a little bit about the script that you are using here?
Sure, Anders. So in vRA, I'm using the extensibility capabilities to run a Python-based script that I've written that through the NSX IPAs automatically creates the firewall rules needed to separate the deployments from each other. So I'm listening for certain events in vRA, and these events will trigger the Python script that creates the firewall rules. And this goes both ways. So when I provision a deployment, a script will create the rules. And when I decommission a deployment, I will also remove the rules after.
All right, that's great, Lars. Good job. So what you did was you used vRA to deploy virtual infrastructure into a NSX guardrail infrastructure. Some of the things may be influenced by the consumer as a day two action. So Lars, can you show us a little bit what the end consumer may do as a day two action in vRA in this case?
Sure, let me show you. So remember the two deployments that we initially did, TP1 and TP2. You can see them also have created a on-demand security group in NSX with a default rule that allows any service to reach the destination. I will now, as a consumer in vRA, change this to allow only web traffic. So again, I'm going into Service Broker. I choose my deployment and I go into Day 2 actions and I want to reconfigure my security group. We can now see the initial firewall rule that was created. So at first, I'm going to remove that rule and then add another new rule. So let's name this allow HTTPS, and I choose the predefined service for allowing web traffic. I'm going to save this rule and I hit submit. In NSX, we will now see these security group that belongs to the TP2 deployment getting updated with the new rule. So here it is. And we can see now the name of the rule. We see the source that in this case is any. the destination is my deployment and it's applied to my deployment, and I'm allowing that traffic. But Anders, hey, it's not any source, right?
Exactly, that is very much the case. So in the application tab, the firewall policy rule says any source to a certain destination on a certain service. But remember that in previous tabs, our isolation guardrails is filtering. They are very much alive and kicking. So they are for sure filtering away traffic that shouldn't be there. So once we, in the end, finally reach the application, traffic that comes this far has been approved by all of the guardrails that comes in the previous firewall rules. So yes, we can safely let the consumer have a day to action of setting certain firewall rules that is applied to only this particular security group. Yes.
All right, but then now when I'm as a consumer, then adding this rule to allow web traffic to reach my deployment, am I also opening up for web traffic to reach my backend servers then?
Well, from a vRA perspective, yes, you do, but from a practical point of view, you don't, because what we did was we set the ingress tag differently on the front end and the backend servers. So from a vRA perspective, you allow HTTPS to enter into your deployment, but since we under environment and isolation, under ingress, we have tagged internet on your front end and no ingress on your backend. So no, we will not open up anything to your backend servers from outside.
Okay, cool.
So Lars, what I want you to do now is that I want you to be the consumer again, and you go into your deployment and you delete it, and let's see that everything is removed. First of all, the deployment isolation under environment, but also the deployment specific ingress rules that you have created being the consumer. So feel free to de-deploy or undeploy.
All right, so I'm back in Service Broker. I can view my two deployments, TP1 and TP2. I will now remove these deployments, and we will make sure that the firewall rules also gets deleted from NSX. So I choose delete on TP2, and I also hit delete on TP1. All right, so both my deployments are now gone, and I move over to NSX. I can see that my virtual machines has been removed. Also, my on-demand security group has been removed. And this is thanks to the out-of-the-box integration we have between NSX and vRA. Also, my isolate deployments rule has been removed. And this is, as you remember, thanks to the ABX action that I mentioned previously, where I'm using the extensibility service in vRA to trigger different Python scripts to, during the provisioning phase, I'm adding a rule, and during the removal phase, I'm also removing that firewall rule from NSX using this script.
So what you potentially may argue at this stage is that it is possible to avoid a blocking dimension by just not putting any security tag belonging to that dimension, either deliberately or by mistake. And when doing so, you expose certain openings further into your firewall rule system. But it's fairly simple actually to use the same reverse logic to make a certain isolation dimension mandatory. So let's take the environment as our example. I click on add a rule, and it doesn't matter actually where it is, but I put it at the bottom. And then if I want to make the isolate environment mandatory, then what I can do is that I take all of my subgroups here. So I bring them into the source field here, and then I go in and I negate that block like this. All right. And then I say drop or reject. So this means, and I have to leave it on DFW here, this means that if you belong to neither of these groups, then I will drop you, and then I apply that to DFW. Applying something to DFW means it's applied to everyone throughout the system. If you have a certain environment tag in this example, then you will belong to either of these groups. So when I negate you, you will not be hit by this blocking rule. So this is a way to make a certain dimension mandatory. Okay, good job, Lars. Good job. So in this short demo, what we have showed is that you can use system-wide guardrails in NSX based on negated blocking and security tags. And we have also shown that vRA can automatically deploy stuff into such an environment, add it, but also remove it. And we have seen that we can be, as a system owner, we can have a saying with the guardrails, but we can leave some of the responsibility for firewall filtering also to the end consumer in vRA. Okay, cool. Thanks for watching.
Thank you.